Hello everybody, welcome to your 6-4 lesson on logarithmic functions. Our learning target for today, we are going to graph logarithmic functions and find equations of the inverses of exponential and logarithmic functions. We'll be able to graph these logarithmic functions and interpret their key features, and we will write and interpret the inverse of exponential and logarithmic functions. So before we get started with our examples, I do want to give you guys a little background on inverse functions. So I'm just going to give you a quick example. Just keep it linear, so an x to the first power. Let's say that we have a function f of x equals x minus 4. So to find the inverse of this function, what we do is we put it into y equals form. So we know that f of x is y is, the same thing as a y. So y equals x minus 4. Then to get the inverse, what we do is we switch the x and the y variable. So we're going to switch this y and this x. They just trade places, and we're going to have x equals y minus 4. And then we will take our inverse function and solve it for y. So we're going to add 4. So we have y equals x plus 4. So you might notice, oh, the regular function is x minus 4, the inverse is x plus 4. All I have to do is change the sign of the constant. This is a basic example, but the process, it's not always going to be it's not always going to follow that. It's not always just change the sign of that extra number on the end. The process is you switch your x and your y and then solve for your y, and now you have an inverse function. The inverse function has a specific notation. Let's call the inverse g of x. Ooh. So we're going to replace the y with g of x. But we put this little, it looks like raising it to the -1 power. That's not what it is at all. That just means the inverse function. So if you see g of x with a -1, that's the inverse function, and then x plus 4. And when I change that to the g, that's going to stay as f. Sorry about that. So we have f of x equals x minus 4. And then the inverse of f of x is x plus 4. So that's just the process we follow to find inverse functions. Just a note on the graph, just so you guys know, that a function and its inverse are reflections of one another across the line y equals x. Y equals x is, if we were to just remember, here's our coordinate plane. Y equals x is just that diagonal right through the origin. If you were to plot this one, or graph this line, you would see that they would be a reflection across that y equals x line. All right, so now that we know what an inverse is and how to find it, then we can just get going with our examples when we get to our inverse example.